All right, folks, let's go ahead and have a look at TypeScript. Welcome to our TypeScript module. So this is going to be part of our JavaScript module, ultimately. It's kind of a thing kind of at the end here. And a lot of JavaScript uses TypeScript. It's really, really important if you're going into the workforce to be able to use TypeScript as well if you're going to be working with JavaScript. What is TypeScript exactly? Well, we're going to go ahead and something I'm really passionate about is making sure you understand how to look at and read documentation. It seems really boring, but we're going to do it together, so hopefully that keeps it a little bit more exciting for you. And so I have gone here to typescriptlang.org. Again, TypeScript is made by Microsoft. And TypeScript is a programming language. It writes very similarly to JavaScript. It's actually a superset of JavaScript. But yeah, so they're talking about like it's working on top of JavaScript, etc. And it's a superset of JavaScript, which means it's like JavaScript but like powered up. It has extra functionality, and it's based off of something called type theory. We're not going to get too far into this, but if you want to learn more about this, there's some really good literature on this, really good YouTube conference talks, which can be a little bit dry, but also, again, if you just want to understand what is type theory, now you have a launching point to go off of for that. And honestly, you probably flirted with type theory in high school math and didn't even necessarily realize it. We talk about unions, things like that. There's going to be symbols and things that will look familiar to you. They don't have the actual symbols here. We can actually look up Wikipedia. Unions, type theory. Union type. And okay, so this is all going to be code related. Wow, that's really upsetting, actually. Some of this flirts with set theory too, but we're not going to get too chaotically into this. Yeah, this gets really, really heady really fast. We're not going to go into that. That's scary. But if you wanted to read that stuff, feel free. Again, Wikipedia actually is really, really good for mathematical topics and computer programming topics if it's about the theory and the science side of things. Not very good for tutorials or how to do things, but will often explain what a thing is. So type theory essentially is kind of this idea that you have different types of things that you can there's rules for how things interact with one another, right? And some of this kind of came as a way to sort of explain the observable world, right? I have some things and I have some other things and I put them together, right? There have to be rules for how we can do that, right? This is like literally the phrase apples and oranges, right? Talks about this exact thing. This is type theory, right? Like can you add apples and oranges? Well, sort of, right? Like they're both fruits. But are they all apples, right? No, they're not all apples. So that would be different, right? And we get this kind of more of an extreme example when we do things like adding strings and numbers together, right? You have this like there's an incompatibility here with what we would expect adding a word and a number together, right? How would you do that, right? But if you have two words, you can add those together, and now they start making a sentence, right? Or if you add two numbers together, you get a new number value. That is what type theory is all about. And in order to create this type system, they start out with something called primitives. And so that's going to be the very first thing we look at here is these primitives, right? And you got to think about the simplest kind of data you can think of, right? And often this first kind of data would be like none, right? And we're used to this in JavaScript. We've worked with null quite a bit. But we also have undefined, and we also have not a number. And there are theoretical differences between those three, but they're really not clear. They can be really dangerous if you get them mixed up, right? Like you can start adding not a number to not a number, and you still get not a number. If you add null to undefined, then you don't have null anymore. There's this very kind of confusing system to this. So TypeScript is basically saying whatever it is that you're doing, whatever operations you're trying to execute, be explicit, right? And so we're going to have a way of writing JavaScript that says, you write your function and you say, I want to have, I require in my code that you pass this function a string and an integer, and I'm going to do something with them, right? And you can even write what you're expecting to be returned from your function, right? So I'm expecting a string and an integer, and I'm going to return an object, right? And so that's essentially what TypeScript is going to allow us to do. That's the real power of TypeScript, is that it's like a bunch of gates, right? And if your code is running, JavaScript usually will say, sure, whatever, if you want to pass a string instead of an integer, we're not going to be that mad about it. We'll just wait until something breaks, and then I might tell you that there's a problem, right? Or just return undefined. And that's not a problem either. Everything's groovy, right? But then TypeScript says if you don't pass these checks, these tests as we go, where we're testing the data type that's going through, then I'm going to throw errors like you wouldn't believe, be very upset, and that's essentially what we're going to be looking at here. So first thing first, right? We're going to look at some of these primitives like string and number. So types by inference, right? You can say let something, and TypeScript will use the value as its type. So you say, what is the type of hello world? It's going to be a string. In this case, TypeScript has read this and said, oh, this is a string, right? Which is nice. And TypeScript builds a type system that accepts JavaScript code, but also has types, right? So you can even just run just plain JavaScript usually in TypeScript, and it should work, assuming you haven't done anything really strange, because TypeScript will actually just infer how that works. But it can be more useful to define those types ourselves and say, hey, I'm going to declare to TypeScript what to expect, and TypeScript will go from there. So again, you can have a user that takes a name and an ID, and in this case, name will be a string, and our ID will be a number, right? Which is great. This is inferred. This is not something that we've told TypeScript yet. We've just given it this thing, and TypeScript has read this and said, oh, well, this is a type string, and this is a type number, so name has to be a string, and ID has to be a number. That's great. But we can also explicitly tell it ahead of time using an interface, right? And so an interface, it looks kind of like an object, but it ends up writing a little bit different. But in this case, we say whatever name we give a user, or anything that is this user data type. We're actually creating our own data type for this object, okay? And this name is going to be a string, and the ID has to be a number. And so what we can do here is we can say const user, and then we use, this is the little syntax here for declaring a type, right? Same thing as we have here. We have these colons and then the data type, right? Colon data type. And we got this one too. We got a colon and a data type, and just the data type is a more complex shape, right? It just has more pieces going on here. So we're going to actually pass this whole interface into this user, and now this object has to have a string for the name, and it has to have a number for the ID, right? See how this kind of works here? If you don't provide an object if you provide an object that doesn't match that interface, TypeScript will warn you. It might still work, but it won't throw any errors. But it will tell you that there's something not right there. And so we've got an interface user with a name string and an ID number. And so we say the const user needs to be of the type user, interface user. And we pass a username Hayes. And as long as we don't have this ID in there, then it will be upset. Once you add the ID, then it's fine and it's all good. Since we've worked with class-based JavaScript a little bit, here's an example of how you do this here, right? And this is actually nice because you can make a new user account, and every time you make this user account, it requires these data types to be passed in, right? So you're still going to give that user to our constructor, or actually this here, once we actually instantiate it. But this is, again, the same thing here, where you have that constructor where it requires a name string and an ID of number. And again, this would be kind of the most full and this is double checking, basically, the way that they'd write it this way. And that would work out. And this would be our return value, right? So our get admin user would return a user interface type, right? So you've declared this interface up here, name, string, ID, number. And so this function, get admin user, will return something of the data type, or the data shape, I guess you can think of it, as user. That interface is going to get returned. Or in this case, if we're deleting a user, you have to pass in a valid user with a name and an ID, which are a string and a number respectively. Composing types, unions. Oh, here we go. Unions here. We've got this that vertical bar. It should be right above the return key or the enter key on the right side of your keyboard. This is going to say it's going to be either one, right? So I'm going to create a Boolean type that has two value options. It can be either true or false. And you can make this more complicated for a variety of other things, right? So, and we'll see this as we get into React, how powerful this can be when you say, oh, I'm going to make something that can only be this many values. If you think about like ternary operators, right? You remember you have, const num number equals 5, right? So that's fine. This is perfectly good TypeScript, right? What we can do is we can say, number equals 5. And if that's true, then we can, you know, console.log hi. Otherwise, this actually needs to be num, sorry. If num equals 5. This is our weird way of, man, I'm all over the place. Otherwise, console.log not 5, right? And this will be fine, this will be valid. And so it's a similar thing to this, right? Where you could say, oh, there's only so many, we have these options of what ultimately can be used here. Maybe not super similar, but you get the idea. Where it's going to be, these are our only legal values for window states, right? And so this can be really powerful in other contexts. And the real value of TypeScript, you have to type a little bit more, yes, but you do end up with a lot more explicit explanations for what things are going to happen. And again, you can find bugs way earlier on, right? You're not going to be likely getting to, we actually see this later on when I get to the Vue content, if you're here for the full course, but you could be making a big app and you're just getting like undefined for something. You're going, what's undefined? I don't know what's undefined. Like, why is this value not coming through? Where is the bug? And TypeScript will find those bugs much, much faster and make life a lot easier, right? You can still use type of here just to see what things are. Undefined is not like banished here. There are times where you're allowed to use undefined. You just have to tell TypeScript to expect that, right? And it's not particularly a good idea, but you could. And then past this, it's going to get a little bit more detailed, and we're not going to get into this too much. Plenty of other examples. The other thing I want to look at here is some of the documentation. So how do we install it? npm install -g TypeScript. Usually I allow things like when I'm making more complicated applications, I'll usually allow you'll use like Vite or Create React App to create them for me, and I'll just say I want to use TypeScript. So again, I can come back here and pull this up, and I could do, you know, npm create Vite. This is how you make a React or a Vue app. So if you're going to be with me for the rest of this course, this will make more sense to you. Otherwise, this doesn't really matter. But I can do this, and I can come down to, you know, say my TS project, and then it's fine. And I can come down here and I can say I'm going to use you know, vanilla, and I can use TypeScript. And now cd my TS project, I do ls, and you'll notice that we've got this tsconfig.json. If I cd into source, you can see that we've got this main.ts, and it's already just put TypeScript in here for me. And actually, this is how you make applications really fast, by the way. I can just install things, and it will install TypeScript in there, and I don't have to worry about actually doing any of the installs myself. And again, I know this is probably a lot. This is where we're heading. This is how applications work. If this isn't tracking for you, don't worry about it, because this isn't the point of this course. I'm just showing that I usually do not actually install it this way. And I can just run this real quick. npm run dev. See how this works. And we'll see this here. There we go. Vite plus TypeScript. And it's that easy. That's how you make websites, which is kind of neat. But yeah. So you could install it this way, or again, I usually just do it the way that I just did for my specific project rather than globally. And actually, some computers, so I'm on a MacBook M1, and the M1 architecture has a bit of a tough time sometimes with especially things that Windows makes, or that Microsoft makes, which includes TypeScript. And so I was having a hard time today getting TSC to work. And so what I'm going to do is I'm actually going to cheat and use Replit. And so if you're not familiar with Replit, I'm a huge fan of what they're doing. They actually have a really good mobile app as well. It's a cloud-based IDE, so you got to think about like it's VS Code but online. It's pretty nifty. So I'll pull up the mobile app too, just for funsies. It's cloud-based, so you can, you know, this is actually the repo that we're going to be messing with today. Instead of repositories, they call them repos. You can get it synced up with your GitHub, so you can just automatically write into GitHub from the web. And sure enough, there we go. We have a little cloud IDE. You probably didn't want to see that, but anyways. And so I can type stuff on here and run it really easily, and that's actually what we're going to do here. So let's go ahead and just look at some stuff. I'm going to break some things. and make TypeScript very unhappy. And that should be just fine. It's just a couple other little things to look around here. We have a build.sh. All this is going to be, when I say build, what's going to happen. So that would be for imagining, like if I was going to actually make this go on the internet and publish it. That's all that the build folder is. The config is just some rules for how to make that build, and then this tsconfig is just some information about TypeScript and a variety of, and you can see other comments here that explain kind of what's going on. One other thing to notice about TypeScript is it does what's called compiling, and that's just one more thing that I really want to talk about here before we start writing actual code, because it's kind of our theory video. So compiling is when you take a more complicated language and you break it down into a simpler one. That is the simplest explanation of compiling, right? Take something complicated, break it down into a simpler language, right? And so again, we know that computers can only actually read zeros and ones. At their core, that's all that a computer can run. As a result, any code that we write, whether it's Python, C++, JavaScript, whatever we end up writing, it has to be broken down into code that our computers can actually read. And there's a variety of ways of doing this. And probably like a really simple example would be you have a program, and it just, when you say, hey, I want to run this program, that program has a program that reads it, right? This is how JavaScript works, this is how Node works for Node.js for backend. It's going to read that code and then break it down for us into just zeros and ones. And at the simplest level, it could just literally just read through it line by line and break it down into binary and then pass that on to the computer. The computer would actually execute that, right? There's also optimization, right? What if you run the same function 10 times? You don't want to write the binary for all of those. So a compiler could run through that and say, oh, you're reusing these. And I'm like seeing patterns with the binary, and I'm going to either compress those or just reuse them, so on and so forth, so that I don't have to worry about doing that multiple times. And that saves space on your computer, helps things run faster, etc. TypeScript does what's called transpiling, which is honestly fairly similar to compiling, and you're not going to get tested on the difference. But basically what happens is our browser can't run, TypeScript, right? And so if I were to go to my console and write whatever it was that I had earlier, I had like what? So we had like const num equal, const num, and we had said this was a number, equals 5. This should not work, right? So const num, number equals 5. It's all set. It says missing initializer in const declaration. But if we go back to here, we should be able to get away with this just fine. Const num, number equals 5. And this is valid TypeScript, right? And it's not mad about it, and I should be able to actually, console.log num, and that should be fine. So there we go. See 5 gets spat out right there, right? And what happened here when I ran run is it actually did that build, and we're gonna talk about that in a second too. But obviously you can see that it actually spat that out. So it read the TypeScript and executed it. But there's also all these steps in between, and if you're looking really closely, you'll notice that there's this index.js file, and Node is actually running that file. So inside of our build folder, we theoretically would have a index.js file, and actually destroyed it after we finished running it. And so TypeScript compiles this shell command here, build.shell, which is inside of here. What this did is it actually made our TypeScript into JavaScript. And that was basically what happened, right? And so what we can do here is we have these different targets. Because our browser, here, listen, because our browser can only run HTML, CSS, and JavaScript. If we do anything else, anything extra, whether that's React, whether that's Vue, Svelte, TypeScript, whatever, okay, all the things that we npm install to make things work better for us, that has to get broken down and compiled to JavaScript. And so that's one of the things to just keep in mind with TypeScript is that your code will eventually get broken down into JavaScript. Fortunately, Microsoft did a really good job with this. And so while we're running our code, it can run TypeScript locally, but then once we actually put it on the browser, it has to be broken down into JavaScript. And so this tsconfig.json is going to be all of the rules about how that will work. If I can just bump this over again. I think I just click on, yeah, cool. So we have all these options here. Okay, so we have this target, and this is ES next, right? And so we can target which version of JavaScript we're going to be breaking it down into, right? So ES5, ES 2015, that's ES6. ES 2016 is ES7, et cetera, et cetera. We have all these newer versions, and ES Next, I think, is going to just basically break it down to whatever is going to be working for the browser. ES3 is the default, and so we can actually just say like ES 2015, and now when we run our build, it will break it down into ES6, ES 2015, et cetera, et cetera. So that's basically what's going on here. We have a variety of other stuff. You'll find out about JSX soon enough if you stick around. And you can change where your input and output, like where your build is going to end up being, base URL, blah, blah, blah. Lots of other stuff going on here. We're not going to get into all of this because it's terrifying and way more detailed than we need to be. So I'm going to go back to index.ts, and now we have this, and now we're going to play around. And I want to make this into a separate window. There we go. Okay, I do not need the show. I want this. Cool. Just clear out that and get rid of this, and we can write some stuff. So first of all, and actually I'm going to make a main.js file here too. That was not what I asked for. New file, main.js. Okay, in this main.js file, we're going to write some things, and our index.ts is going to yell and scream about them, and JavaScript is not going to care. So I can do 3 plus an array, and this is fine, right? JavaScript will not care. If I go back over here, we're just going to, sorry, Google, 3 plus an empty array. And again, we did this before in our JavaScript studies, right, where we looked at the types, which are really one of the weakest parts of JavaScript. We looked at our types and things like this where JavaScript's like, yeah, that's cool and fine. If I go back to my index.ts and I do 3 plus array, this will be mad. And we hover over it and it will say operator plus cannot be applied to types, number, and never. And you say, what on earth is never? This is actually another data type, which, let's see what this has to say about it. Never is a special type, the opposite of any. Nothing can be assigned to it, right? And that actually is an interesting thing we can do here too, is I can make a new variable called const whatever, and this will be any, equals, and I can do whatever I want to with this, right? I can set this to 5. I can set this to happiness, right? Whatever I want to do, I can assign to this, and that's cool, but also this kind of takes away the power of TypeScript. So if you're just going to put any on every single one of your variables, you can run into some problems, right? Because what if I'm expecting a number? What if I'm expecting a number? This is allowed, right? And you can add whatever to whatever you want to now, and there will be no errors. No, there will be no problems, right? Because TypeScript will actually have been disengaged from anything that gets put into whatever, right? So that's kind of our first one. I'll just kind of stick down here and keep typing these. So 3 plus empty array. Let thing equals empty object. This is fine in JavaScript, and I believe let thing equals empty object. This ended up actually working, but here we have this problem where I can say thing.foo. I can just log it, right? Console.log thing.foo. And now we have an error here. It says, oh, property foo does not exist on type thing or on type or an empty object, right? So wherever we try to get this from thing, there's no foo value, right? I can fix this by saying, foo equals bar, right? And now it'll work, not a problem. And I can just run this here, bloop, and it spits out bar. That's great. But again, if this does not exist as an attribute, as an element of thing, then we will have an error. And again, here it will not care. Console.log thing.foo. Okay, no problem. I actually have a hint here. And again, it's because TypeScript is inside of here. And what's happening is this tsconfig.json is actually going to read all of my files. But if I come back here and let thing equals an empty object, and then I console.log thing.foo, we just get back undefined. No error, no problem. Everybody's happy. Life's good, right? Not what we want. And And again, this is because TypeScript is reading other things. You can change that setting in your tsconfig.json. You'll hear me say that a good bit here. Let's do another thing here. So we can say function C takes D. What does it do? It returns D divided by 2, right? Okay. What we can do is we can console.log. We do C, and we're going to pass in Z. Okay, and not a problem. Why is this not a problem? This should be a problem. And we're going to get not a number, I believe, or no, just undefined on this one. Oh, I think this actually broke here. I'm just going to pass this one. Maybe we can just do node main.js. There we go. So we get not a number, right? And this actually ended up running, it actually built the index.typescript because that's what it's looking at, and put it someplace else. But when we run main.js, we get not a number. By the way, node will not work index. Will not work here. So it did not, actually it just ran it as regular JavaScript is what really happened here. We got undefined there, we got undefined here. It's still mad. And so that's just something to notice as well, is that you can still kind of blow through your parameters. TypeScript is really meant for the developer. It's not meant for the user side. It's meant to throw errors before you ever actually put this on the web. Because again, this will basically either get changed into usable JavaScript or it will get handled as usable JavaScript if you don't use any of the TypeScript stuff. So just a few more examples there. We got some more stuff we're going to look at here in a minute. I've been talking for 26 minutes. I think that's been plenty. Hopefully this has made sense. And we're going to get a lot more experience with TypeScript in future modules and bigger projects, but figured I'd toss this in here and start to explain a little bit about how TypeScript works and what it is before we are trying to figure out how to write React and TypeScript at the same time. So see you in the next lecture. Hope this is working for you. See you there.